Optimization. Preparation for calculus. Let us look into a test question which is based on optimization. Anil's house is 20 kilometers south of Ben. At 6 a.m. in the morning, Anil leaves the house and jogs east at 6 kilometers per hour, and Ben jogs south at 8 kilometers per hour. If they jog for 2 hours, find the time when they were closest together. You can pause the video, answer the question. Welcome to your YouTube channel, absolutely free for the last 15 years. A learning platform where you post questions, we provide solutions. In case you need any solution, you can send an email to globalmathinstitute at gmail.com. Also, visit our website globalmathinstitute.com. Now, let's try to understand how do we solve such questions. First and foremost, try to sketch the diagram, understand this situation. Anil's house is 20 kilometers south of Ben. So let's say something like this. Okay. So we say Anil's house is here and Ben's house is there. And the distance between them is 20 kilometers. Makes sense. So Anil's house is 20 kilometers south of Ben. At 6 a.m. in the morning, Anil leaves the house and jogs east at 6 kilometers per hour. Right? 6 kilometers per hour. So with time t, it will go 60 times, right? Ben jogs south 8 kilometers per hour. So this is 80. If they jog for 2 hours, find the time when they were closest. So the closest distance is any time the distance between them, right? So that becomes the closest distance. Let's call this as S. So that becomes your diagram, right? Now, how much is S? You can use Pythagorean theorem. So at any instance of time, you see the distance S can be written as equal to this square. Now this square is 20 minus 80 plus 60 square. Is that clear to you? So basically that is distance square, or I could do square root of this, right? So using Pythagorean theorem and how much distance they cover, we can write down our equation to work with. Now here, we're also given one thing, that time t, they jog for 2 hours. So time is between 0 to 2 hours. So it's a boundary condition given to us. To find the closest distance, we can actually find the derivative, critical numbers, and then check whether it is minimum or not. So let's find the derivative with respect to t. So half of all this, right, which is square root of 20 minus 80 whole square plus 60 whole square, correct? And in the numerator, we get the derivative of the function itself. So the first part derivative will be 2 times 20 minus 80 times minus 8, right? And this will be plus 2 times 60 and then 6. So we can write 12t, correct? You could write 2 square. I mean, do you understand? You could either write this as 36 squares and then If you want to write like that, you can write 2 times 60 times 6. You can do like this also. Or you could first square it. You get 3060 squared. And then 36 times 2, 72. So that's what you get in the numerator. Correct. Now, I'm keeping it very simple. You understand this derivative, right? Critical number is when this is 0, right? So, to find the critical number, let me equate this to 0. Practically, it means that the numerator is 0. Yes, I could have crossed out 2 also, but I'll do it later. Or let us do, we can cancel these 2's. Okay, no problems. So we have minus 8 times this plus 36t, right? So this basically means that minus 8 times 20 minus 8t plus, let me write this as 36t, equals to 0. Okay, so let's open the bracket and find what t could be, right? So minus 160 plus 64t plus 36t equals to 0. Taking 160 to the right side and adding this up, 64 plus 36 is 100 equals to 160. So t equals to 160 divided by 100, which is 1.6. So we get our critical number at t equals to 1.6. Clear? Plus we know boundary condition, which is t is between 0 to 2. Basically, now we need to find the values of s. Let us do it on a fresh page. So for this example, we got critical number at t equals to 1.6. And for us, s was equal to square root of 20 minus speed 80, right? Whole square plus 60 whole square. Right. We also know that t is between 0 and 2. Correct. So we'll plug in 0 first. So we get what? Square root of 20 minus 0 whole square plus 0 square, which is 20 square square root or 20. Right. Now let's plug in 1.6. So if I plug in 1.6, I get 20 minus 8 times 1.6 whole square plus 6 times 1.6, right? Whole square square. Let's use the calculator to calculate this value. Correct. So we get 20 minus 8 times 1.6 whole square, and it comes to square root 144, which is 12. Also, let's calculate the value at 2, which will be 20 minus 8 times 2 whole square plus 6 times 2 whole square root, right? So that gives us 20 minus 16, 20 minus 16, 4 square, which is 16, plus 12 square, which is 144. So it's definitely more, right? It gives me 12.65, I can write. So, definitely from here, what you notice is that the minimum distance is at 1.6, right? So, 1 hour, 1.6 hours, right? So, what will be the time in this case? So, 1 hour, 1.6 in hours will means 1 hour, and zero point 0.6 means 36 minutes, right? 6 into 60. So, zero point 0.6 into 60. So, that means at 6 plus 1 hour 36 minutes means at 7:36 hours they'll be closest. Makes sense, right? So that is how we are going to solve this particular question. I hope it makes sense. Feel free to write a comment, share your views. In case you want question papers and more help, send an email on globalmathinstitute@gmail.com. You can also visit our website for an update. Thank you.
Who is this book for? Middle and high school students who want to go beyond the classroom? Future STEM leaders looking to develop problem-solving and analytical skills? Anyone who loves math and wants to see its real-world applications in AI, physics, and engineering.
Are you ready to explore the mathematics of the future?
Crack the numbers for future STEM leaders. Sharpen your skills, shape the future. Available soon. Visit our website to pre-order your copy and unlock your mathematical potential today.